So in the first part, actually we stopped it at here, where we need to calculate the target values for aim pitch and aim yaw. Right. So I'll first start calculating the aim pitch target value. So to do that, actually I need a function. But yeah, since we have these variables outside, I think it would be nice if we organize these stuff properly. Right. So I'll assign these to category called, I don't know, maybe aiming data. Let's assign everything to this category. Okay. Right. Now let's create a new function called get aim offset pitch. Right, and this function should be thread safe because we are going to use it in a thread safe function, and this should be a pure function as well because we just need to determine what's the pitch. Right, we are not going to modify anything inside this function. Right, so how to calculate pitch? Well, we can use the property access, and let's get try power nowner, and there is a thing called get base aim rotation. Yeah, we have this get base aim rotation, which gives the aim rotation for a specific point, right? And as the second property access pin, let's get the try get power nowner, and let's get the actor rotation. We have actor rotation. At where? Yeah, we have get actor rotation here. And then let's get the delta of it, right? So basically this will normalize these two rotators, and I'm interested on only the pitch value, right? So let's break the rotator. This is the value that I'm interested, and let's normalize the axis, and I'll clamp it based on a specific range actually. So clamp float, the range is basically pitch range, right? So I'll break it, and as the x, this is the min value, as the y is the max value. Okay, then I can return it to here. Right, so before I actually plug into the update aiming data function, let's debug it and see whether it's returning the values properly. So I'll call this on event blueprint update animation function or event, and let's add it to here. Right, so let's play. Okay, it's updating properly. So just don't just ignore these stuff. It's currently remaining at the TPS because we plugged this full body aiming thing to here, but we haven't plugged it to here, right? That's why actually it's remaining in the TPS, but for now, just for the reference, I will plug it to here, compile and save, so it will be playing the locomotion state properly. Right, so it's double printing, so let's go for a different component and try to play, and now it's not double printing. I can see when I look up, it's a positive value, and it would be clamp at most until to the 90, and if I look directly, it sort of close to 0, right? And if I look down, it goes to minus 90 at most, right? The value is actually clamped and it's updating properly. Okay, so I don't need this thing anymore. Instead, we can plug this thing to update aiming data. It aims offset pitch. Yeah. Another, I'll assign this to blueprint thread safe functions. Okay. And similarly, we need a function to calculate yo as well. So I'll create a new function and call it as get m offset yo, which is a pure function and thread safe. And I think yeah, I think we can use the same rotate thing that we used here. So I'll copy everything and go to the term set yo. And here I'm not interested in yo. Right. And the clamp float should be there, and we can simply return the clamped value. We can get the yo range, break it, plug it to here. But this value can be different if I have the root yo offset, right? So if you remember, actually for the turn in place, we have this disable root yo offset thing has been already set up. For example, I'm basically checking at here. If I disable the root yo offset, which means we are not rotating the root bone, which is 0. If it is not, which means the root yo offset is unable, then we are taking the root yo offset. So similar logic we have to apply to calculating the m pitch as well, m yo as well. So I'll copy these two nodes and paste it here. And if we disable the root yo offset, we can get whatever the yo value provides at here. And if we are not disable the root yo offset, then we can update the yo based on the root yo offset that we have been already calculated at here, right? So I can use this one, but it should be inversed, right? Therefore I can multiply it by -1 and plug it to here. So it's simply an optimization technique, right? Because since we have been already calculated this root offset, we don't need to recalculate it again if we are going to enable this root offset, right? So only if we haven't enabled the root offset, we have to recalculate the yo again, right? Otherwise we can simply use the existing variable, right? Because you have to be very careful when it comes to these sort of calculations, because they are going to execute these calculations for each frame, for each character, right? Okay, so then we can plug it to here like that, and it will return this value. Okay, So like we did before, let's try to print this one as well. I'll use this one. Compile and save. Let's go to the component level and play it. Now you can see when I'm rotating, actually the yaw is updating, right? So since I enable the root to offset, the character turn in place also work. Plus since the turn in place works, the yaw is updating accordingly as well. Okay, great. So I can remove this print statement, and let's go back to set update aiming data, and as the target now I can use this function, which is get aim offset yaw. Okay, and I'll move this to blueprint thread save functions category. Compile and save. Right, so now we calculated aim pitch and aim yaw, which means we can go and implement full body aiming and aim layer. So I'll reconnect this to pre-aim pause, compile, and then let's get aim offset player. Okay? This one is used to play whatever the aim offset blend space that we need to be played. And as the blend space, I'll expose this as a pin, right? And alpha value, I don't need to expose it as a pin, so I will keep it as binded, which is default 1. Okay, and then I can use that aim offset at here, and as the base pause I can use that pre-aim pause, right? And these x and y values are basically our calculated aim yaw and aim pitch, right? So first I will get the aim yaw, and since we have enabled the rotation modes as well, we need actually determine whether we are going to use which aim offset. So I'll add select. No, let's first get property access. I'll get the movement component, and let's first check whether we are orient rotation to movement or not, and based on that I can select certain values. So if we are not orient rotation to movement, which means we are forward facing, therefore we can use the aim yaw value. And if we are orient rotate to movement, which means we are at strafing mode, then we can use the root to offset. Get root to offset. So the aim yaw and root to offset should be appended together, and we can return the final value. Okay. And since I have this aiming offset as well, I can add a certain offset for our aiming offset as a pre-calculated static value. So I will add this to here. So for the aim yaw, I will use the x value like this, and at attach it to X. Compile and save. Yeah, so this is basically yo. And similarly, let's calculate pitch as well. For pitch, actually, we don't need to consider the orient rotation to movement. Right? Basically, the rotation mode won't be considered because pitch is either way the vertical movement of the AME. Right? So it doesn't involve any sort of rotations. Therefore, we can simply add the existing aim offset aim offset y value with the aim pitch and simply attach it to y. Okay, so we have aim yaw, aim pitch, aim offset, and the base pose. And now I can save this to a new cache pose called maybe aim pose. Okay. And then maybe I'll comment this thing as aim offset blend space. Okay, and then now we need to blend these aim poses together, right? So we have pre-aim pose and we have aim pose. We have to blend this stuff together. Okay. So the obvious blending is we can use blend poses by bool. Blend poses by bool, right? As the bool value, we can use this one is valid aim offset. So if we have a valid aim offset, we can use the aim pose. If it doesn't have a valid aim offset, then we have to go with the pre-aim pose, which is the base pose. And we can promote this to another cache pose. I'll call it as final pose. And for the blendings, I'll make this as 0.2. Okay. And additionally, since we have this specific targeted aim offset blend name, we can use that as well. So I'll use blend poses by bool. I'll simply check whether this one is empty or not. So if this one is empty, we go with the true pose, which is this one, aim pose. So if this one is empty, we will simply apply the existing aim offset. But if this one is false, which means we have a pre-configured aim offset blend space name, therefore I'll go with the pre-aim pose. And the blend by bool values, I will use this as 0.2 and plug it to here. Right, so the false pose is pre-aim pose, valid aim, final pose. Okay, and I'll comment this as blend pre-aim and aim pose based on certain conditions. Okay, and finally we can use the final pose as the output pose. Okay, compile and save. Yeah, good to go. Right, so now I can play, but it won't apply any sort of aim offsets yet because we currently haven't add any sort of aim offset blend space to here, right? So as the third part of the aim offset section, I will cover this one, like how we can create our own aim offset. And yeah, I'll see you there. Thank you.